Okay, so we have two-column proof with congruent triangles. Once you have your figures drawn and the given and the proof listed, you take a look at the picture and you have to decide how we're going to prove two triangles are congruent in this picture. Okay, so we have some information here. We're told that AC is congruent to DC, and that's already marked. We also have the fact that this is a right angle, so the other side has to be a right angle. Okay, and then clearly we have a shared side. So what would the theorem be that's going to prove these two triangles are congruent?
SAS.
Right angle side, I agree. When you're doing this, I want you to write that down. Okay, this shows me that you've thought through that process and you know exactly what theorem you're going to use. And then, now, we are going to prove that these two triangles are congruent, but really what they're asking us to end up with is that angle A and angle D are congruent. So once we've determined that the two triangles are congruent, then because the two triangles are congruent, all of the parts of the triangles are congruent. Therefore, we can use what's over there on the board, corresponding parts of congruent triangles are congruent, right? Got it? Okay, so we are going to use side angle side, and then we'll use the CPCTC to prove that A and D are congruent angles. All right, here we go. Once you've made this choice, you just need to prove this. So starting with 1, I need to prove that a pair of sides are congruent. And that's going to be this first given statement. AC is congruent to DC. So our reason here is given. It's 1. Done a pair of sides. Write it down. Check it off. Write it down. Now we need to prove a pair of angles. So we have these right angles right here, right next to each other. So I'm going to list those two. This is BCA. So angle BCA is going to be congruent to angle BCD. And because the reason that they are congruent is because all right angles are congruent to each other. So we say right angles congruent. Like my abbreviation there. Right angles are congruent. So I've proven the pair of angles. Now I need to prove the last pair of sides. And that will be the shared side. BC is congruent to BC. Does anybody remember what that reason is? I think we talked about it last time. It actually is a property.
The sharing.
Reflexive property. When a side or an angle is shared and it's exactly the same thing, BC equals BC, we call that the reflexive property. So there we go. We've got our side angle side proven. Now we can say which two triangles are congruent. So we're going to say triangle, don't forget the symbols, A, B, C, is congruent to triangle D, B, C. Now the order that you write them in is very important. Our reason is side angle side. And now we can see just from our congruent statement that angle A is going to equal angle D, which is what we were trying to prove in the first place. So we can go right to that point and say that angle A is congruent to angle D. And this is by corresponding parts of congruent triangles are congruent. And we're done. That is a two-column proof.
So we're going to have to write that for every problem we do.
It all depends, okay? So I get that question every time. Each proof is going to have a different set of steps. And they aren't all going to be exactly the same. They're similar in terms of you pick a theorem, you prove the theorem, but maybe you have to do this part, maybe you don't. Some problems are going to end right here because that would be the proof.
They just ask
If it says prove that angle ABC is congruent to angle DBC, then you stop right there. You've done it. Depends on how far you have to go based on what they're actually asking you to prove. Okay, pretty basic one there. All right, the next one is also a basic one. So, number 2.
Can we try and do it by ourselves? Like, just tell you?
Let me get through this, and then you're going to have some to do by yourself.
I should just kind of like complicated.
All right, so remember, you want to look at what's given, and you want to look at your figure, and you want to determine what theorem you're going to use. Okay, so that we're given that B and E are angles that are equal. Now, they have already marked those. And then we're also told that point C is the midpoint of BE. Okay, that's kind of marked as well. That is that we see this situation right here, BE and C is the midpoint, so they've marked those two as being equal. All right, now, what else do you see in the picture that's equal that's not marked?
The vertical angle.
Yes, there are some vertical angles here.
So it's going to be angle, side, angle.
I agree. Angle, side, angle. Okay, angle, side, angle. Now, that's going to prove the two triangles are congruent, but we actually need to prove that these two sides are congruent. So we're going to prove that the two triangles are congruent, and then, again, we're going to use the CPCTC. So that's the strategy here. All right, one at a time. This one has an extra step, so you want to be careful and understand why I'm doing it. So I'm going to start with a pair of angles, which is given. So we'll say angle B is congruent to angle E, and our reason is given. So we've done a pair of angles. Now we need to do the pair of sides. Although the problem here is that this statement doesn't actually tell us that the sides are congruent. Okay, so we need to put the statement in before we can actually say that those two pieces are congruent. So step 2 is going to be another given point, and I'm abbreviating here, C is the midpoint of BE, and this is also given. But what does that cause to happen? If you know that C is the midpoint of BE, what does that cause to happen?
Makes the two sides equal.
Right, it makes these two pieces equal that are marked up here. So BC and CE are congruent. And they're congruent because of that midpoint. So what you write is definition of midpoint. It is the definition of the midpoint that makes those two pieces equal to each other. So that's our side, pair of sides. So we have an angle, one pair of angles, one pair of sides, and now we need another pair of angles. And as someone pointed out, the angles that we need are the vertical angles. So be careful how you list these. Step 4 is going to be
So, how do we prove it?
BCA is congruent to ECD. And that is by vertical angles.
How do you show the order?
Okay, I started with this angle that's marked,
Does it matter?
BCA, so I'm going to start with this angle that's marked, ECD.
So you just start with the same angle.
Right. Make sure that your vertex is
So
listed in the middle.
could it have been ABC,
Y'all are getting a little restless. You still?
DC or DEC? ABC and
E, if you say E in the middle, you mean this angle right here.
yeah.
C's got to be in the middle to mean the vertical angles. C's got to be in the middle of your angle statement, your angle name. Okay, this is enough to prove the two triangles are congruent, so now we're going to list those. Triangle ABC is congruent to triangle DEC. And that's by angle, side, angle.
Paige,
Yes?
for number 3, couldn't that be given?
No, it's not given. This is what's given.
But
From the given, we know that these two pieces are equal because the definition of midpoint.
But since it has like the markings on it, it's still not given.
Right. Right. We go with the words they give us. Okay, so we're almost there. If we know that these two triangles are congruent, then we know that the pieces, the corresponding parts, are congruent. So we're at the end, AB is congruent to DE by corresponding parts, congruent, triangles, congruent.
How many steps are you supposed to have?
It's going to be different for each problem.
How do you know?
You stop when you get the proof. When you match the proof, that's when you stop.
So number 5 when I saw the A.
Right. If that had been where you were stopping at this, if your proof had been proof that triangle ABC is congruent to triangle DEC, then you stop there. Okay, if that had been up here where it says proof. Okay, you got to stop where it says proof when you get there, and make sure you get all the way there. All right, you ready for the big one? This is a tougher one, guys.
My brain is
Okay, so a lot of markings are already on here for the statements that they give. So we do have that we have a couple of right angles. You can see that. And we also have that we have two smaller angles that are congruent, and they're already marked as well. What I want you to notice is where we're going in this problem. This is asking us to prove that these two triangles are congruent. Now that's STR, I'm going to shade it in, and QTP. That's these two triangles up here. Now I want you to notice that even though you might, does everybody see the vertical angles in the middle at T?
Yeah.
Okay, that is helpful. And we're going to use those, but really and truly we don't have enough information to straightforward prove that those two triangles are congruent. We don't have quite enough information. So we're going to actually prove that the two triangles, I'm going to cover up that center line, that diagonal like that. We can actually prove that these two triangles are congruent because we have enough information for that. So one of the things that you're going to see is suggested is that when you have these overlapping triangles, they're called, to kind of take them apart and try to get rid of that overlap. So what I'm going to do is not draw in that QS line and get my triangles drawn like this. Okay, and then we know that this is congruent and this is congruent. So now, looking at this figure, how can we prove that these two are congruent? All right, we have a pair of right angles. We have a pair of angles that are given and a shared side.
So, side angle, angle, side angle.
Almost. Angle, angle, side.
How?
Okay? Angle, angle, side.
Can it be,
Angle, angle, side.
can it be angle, No, because they're on opposite sides, the middle part, that's what I.
Alright, so, now, how does that help us though? Alright, once we've proven that these two triangles are congruent, then that makes all their parts congruent. So then going back to what we need to prove, we have a pair of angles here, we have a pair of angles here. Now that gives us these sides. Because if these two are congruent, then PQ and SR are congruent. So if we know that from this proof, what theorem can we use now to prove that the two yellow ones are congruent?
Vertical angle.
You know you have vertical angles, I agree. But what's the theorem?
Angle, side angle.
Almost.
Angle, side.
Another angle, angle, side. So this one is a long proof. We're going to prove angle, angle, side twice.
I didn't have to do this side. Yeah, how do you know what to do it twice?
Okay, so, shh. Okay. I started by taking these apart and showing that, and shading these in, which is what we're trying to prove, and realizing that I couldn't just do it straightforward. I couldn't do it without some help. Okay, I couldn't do it without some help. So I needed to prove these two triangles congruent, so that I could prove these parts were congruent, so that I could then go over and recognize that with these parts congruent, now I have enough information to prove those two triangles are congruent. So it's all one related into the other. Now, you aren't going to have very many of these that are going to take as many steps as this, but it's about the logic, guys. It's about the reasoning. So if you can get the reasoning of one of these long ones, my hope is that you can then get the reasoning of the more complex, of the simpler ones. Okay, so we're going to start with proving these two. We need angle, angle, side. Here we have the two angles given to us already, so I'm going to start with those two given statements. So we have angle PSR congruent to angle PQR, and this is actually right angles are congruent, okay? In step 2, angle QPR is congruent to angle SRP, and that part is given. All right, and that is our angle, angle, and now we have the shared side. PR is congruent to PR. What's that property? Reflexive. Okay, there we've proven two triangles, so now I need to list them. So triangle SPR congruent to triangle QRP, QRP, and that is again by angle, angle, side. Now, remember our goal here in proving this was to actually prove that these two sides are congruent. So PQ is congruent to SR by what? CPCTC. All right, and this is actually going to be the side for this pair of triangles. So we actually are already moved into the second set. Now we just need to prove these two angles. And one of them is a given. So I'm going to go back and write this given again to get my other pair of angles. And I would say that it's possible that that's one step that you don't have to repeat another given, but I'm doing it just to fit these together because they are separate. They do go together. So I did the same given again. I'm sorry? Right, and that was to prove that these two, but our goal is to prove this, that the two yellow triangles are congruent. All right, so now we're gonna prove those angles in the middle. Please be still, quiet. The angles in the middle are vertical angles. So angle P, T, Q is congruent to angle R, T, S, and our reason, vertical angles. Almost there. That gives us those two yellow triangles. So 8 steps, triangle STR is congruent to triangle QTP, again by angle, angle, side. So in math, when we finish a proof, we like to say QED, which is a Latin phrase. Complicated thing, but like to say quite easily done.
What? Wait, what's so complicated about that?
Is it a joke?
Kind of.